my background academically is computer science and philosophy, and my work has been about kind of the relationship between those two fields. What do we learn about being human by thinking about, the quest to create artificial intelligence? What do we learn about human decision making by thinking of human problems in computational terms? And so the themes that have interested me over the years have been, on the one hand, this species level question of like what defines, human intelligence at a species level, and secondly, at an individual level, how do we approach decision making in our own lives, and what are the problems that the world throws at us? And so now I find myself interested at kind of the group level, the society level, the civic level. In a couple different ways. So one of these is in the field of journalism. I feel like stepping back for a second, I feel like in the sciences there's this really profound movement happening right now towards openness, reproducibility, the sharing of models, the sharing of data, and I've been really encouraged by what I've seen over the last few years in terms of the norms of the sciences are changing. So it used to be that people were very scared to publish their models because that was kind of the secret sauce. That was their advantage over other research groups. And, for example, in the field of deep learning, there's this group at Berkeley that just sort of put their models out on the internet and said, here they are, here's the secret sauce, here's the secret recipe. And what happened was that their work became kind of the touchstone work that everyone else was using and everyone else was kind of working in reference to. And I think the more profound thing there is that they're recreating the social norms of the field towards a mode in which if you don't share your models and you don't allow others to reproduce your work, it's considered suspect. That to me is a really encouraging trend. And so where I get interested in this is applying that more into a civic space and driving towards the idea of reproducibility in journalism. So, you see, you might see a chart in a journalistic piece that says, this is the crime over time, or this is the mortgage rate over time, or something like that. And if you're lucky, you'll get some line at the bottom that just says like source, Energy Information Administration. Mm-hmm. That might be the most that you get. There is nothing remotely approaching the level of like reproducibility that the sciences hold as the ideal. There's no way for a citizen to rebuild that chart and that analysis from first principles. So this is something that really interests me. I'm trying to, I'm working with a group of collaborators to see what can be done basically at the intersection of computer science and journalism to create ways for people to present their stories and their claims in a way that can be reproduced. So this is something that I think about all the time as a citizen. I'm always reading stories and trying to scratch through the headline to like the data source that's driving the headline. For example, I'll see a claim that says, just here's a topical one. San Francisco median rent stabilizes month over month for the first time in X number of years, and that it makes for a good story because there's something of short-term interest that's happened in some time series, right? But it's very rare that story will provide me a way to see the historical data and look at the time series for myself and come to my own conclusions. So, for example, there was a big, I remember in Obama's most recent State of the Union, he was talking about the unemployment figures, and he said, we've created, I think it was 14 million jobs since I came into office, and this was kind of rebutted by factcheck.org that said, well, he's counting from the bottom of of the recession, not the beginning of his term in office, and he's only talking about the private sector. The public sector is still net negative. And my attitude in this case is, if the claims and the charts were being provided in a form that showed the work, we would not need, a point counterpoint in prose. I just think prose is kind of a long medium for that. So this is one of the things that I've been working on in the civic space, is thinking about how to provide the tools for someone to make these claims in a way that's reproducible, that includes the actual model building and the assumptions. In some ways, I think of it as a problem with a pretty straightforward technical solution, but there's also a cultural solution. So, I'm very encouraged, for example, at a technical level by the Jupiter project. So this is started out of UC Berkeley, and it's a platform. It's a web platform for reproducible data analysis. You can include blocks of prose. You can say, okay, then we did this, and you just include a block of computer code that's runnable in the browser and generates the figure right there. And so this is something where this has gotten really widely adopted in the data sciences, in like I said, the hard science community, and I'm interested in bringing this to the civic space, and making a version of this that journalists can use, and that we can use to make something that actually has an impact on citizens. So take this thing that's used by scientists, and carry that over into the public sphere more broadly. I think journalists in particular can be a prickly bunch in the sense that the social norms in journalism, when a journalist does an interview, they take notes, and they'll publish certain quotes from the interview, but they have this larger set of notes, and they don't publish the notes. In fact, they often don't share them with their own colleagues. And so part of the question here is, I see this as parallel to the problem in the hard sciences. How do you try to create a new it's kind of like a prisoner's dilemma. If everyone's trying to hoard their information, then it kind of makes sense for you to do the same. But if everyone's sharing their information, then it makes sense for you to do that too. And so I think it's fair to expect that if a claim cannot be presented in a reproducible form, then we kind of don't trust the claim. And so, if a politician cites a particular figure, I think it's right to say, where did you get that number? Where did that come from? They don't always disclose it, but I think it's appropriate to create a norm around this where if they don't, then we treat it with total skepticism. If you're going to use the Energy Administration figures, then you have to actually provide, let's say we imagine you actually have to provide some kind of Jupyter notebook in which you say, okay, here's the code by which I scrape those. I'm actually building a prototype of this, and I'm working with some designers and data scientists and a group of people, including some of the people who work in the hard sciences on these notebooks, and we're trying to make something. So it remains to be seen what the adoption will be, but every time I talk to journalists about this, they immediately recognize the problem, and people seem genuinely enthusiastic. So, this is probably half of what I'm working on right now. And academically, my background is computer science and philosophy, and I have thought of each discipline in the terms of the other. And so in philosophy, your training is in assembling and disassembling arguments. someone lays out a case for X, and you're trained to kind of pick apart that into its component pieces and find the weak link and attack the weak link and so forth. And having that training in parallel with being trained as a computer scientist really instilled in me this fundamental belief that prose is just the wrong form for a lot of the discussions that we have in civics. When I was in college, I judged a debate tournament, and it was pretty eye-opening for me to think about live rhetorical argument making as being this kind of very strange genre that really doesn't have the properties that you would want for civic discourse. So if someone goes up and makes a 10-minute long speech, they make, let's say, a dozen different arguments for their position. The other person goes up to make a 10-minute long counter speech, and they just choose the one of those 12 arguments that was the weakest, and they spend their entire time hammering away on it, humiliating the other person. And, if you're not paying attention, you come away with the impression that the second person has won the debate, when in fact there were 11 unanswered arguments in favor of the first group. And so it's always felt to me for at least 10, 15 years that, prose is just the wrong format. I think, televised debate is especially bad, but even written prose is really complicated. And so someone who's been very influential in my career is Douglas Hofstadter. So he, writes this book in the 70s, Gödelischer Bach, which is this kind of insane genre-transcending book about number theory and music theory and visual art history, and it ultimately sort of makes this argument about human consciousness. So I think of Hofstadter as someone who, especially in that particular book, really just rode totally roughshod over the division between computer science and philosophy. He's saying, I'm going to turn to typographical number theory to make an argument about, what makes human consciousness. And so encountering that as a teenager was hugely influential to me. And, at the broadest level, my thinking in my work life, but just my approach to life has been driven by this conviction that there is a really profound relationship that exists between the biggest questions, the biggest philosophical questions, and the formal rigor that arises out of thinking about things in mathematical or computer scientific terms. I think of cognitive science as being one of the major estuaries, if you will, of computer science and philosophy, and that's been one of my major interests since the very beginning. And you mentioned Daniel Dennett. He's someone who has been coming up a lot for me in the other body of work that I've been doing, which kind of tackles the intersection of computer science and civics in a totally different way, which is thinking about ethical questions with respect to artificial intelligence. So Dennett has this speech from the 1980s called the Moral First Aid Manual. And he talks about there's this major problem in his take within the field of ethics, which is that it assumes kind of unbounded computational power in the person making a decision about what action is the correct good action to take. And you think about this, for example, in the trolley car problem. There's this famous thought experiment. There's a trolley going down the track. It can hit one person or 5 people. You have this lever, or you can maybe throw someone in front of the train or whatever. I was talking. Many people have made the point that this is one of these very very abstract things that kind of lurches into being a practical problem when you start talking about self-driving cars. And so I was having a conversation with Peter Norvig at Google about self-driving cars and the trolley car problem, and he made the point that, yeah, I mean, if you're programming a self-driving car, it's a little bit more like, okay, you have a trolley going down the track. On the one side is one person, on the other side is 5 people. There's this button that you can press that will have it up. Too late. You only had 50 milliseconds to make the choice. And so it's just a completely, like, when you take computational constraints into account, it's just a completely different problem than it is if you have this kind of pause button on the universe where you can just sit and kind of think about the concept. We're now just sort of careening into this world where these things become practical problems. So I think the way that we studied prime numbers for hundreds of years, just for the pleasure in doing so, and mathematicians have boasted about how useless prime numbers are. I think Hardy said it was the most profoundly useless branch of mathematics. And then all of a sudden in the 20th century, with the advent of cryptography, it becomes extremely important, and now like the global economy is riding on these enormous prime numbers. I feel like we're basically seeing the same thing happening now with these ethical thought experiments that have just kind of festered in philosophy for decades or more, now all of a sudden becoming practical problems that we need to figure out some kind of provisional answer to. I'm really keenly interested in basically the next 10 years from the perspective that, as AI moves into these things, not just self-driving cars, but there's a big news story in the last month or two about algorithms for parole, deciding who should get parole. We've trained these machine learning models to predict recidivism and so forth, and ProPublica did this big investigation and found what appeared to be a bunch of racial bias in the output of this algorithm. And so this is another case where AI, in this case machine learning methods, are intersecting with these ethical and civic questions in what I think is ultimately a really promising and potentially very productive way, which is, as a society, we have these values in kind of maxim form, like equal opportunity, justice, fairness, and in many ways they're deliberately vague. That's what allows things to be kind of a living document that stays relevant. Is this deliberate flexibility and ambiguity? But here we are. We're now in this world where we have to say of some machine learning model, is this racially fair? Is this just? And we have to define these terms, computationally or numerically. I think in the short term it's really problematic because we just have no idea what we're doing, and we don't have a way to approach that problem yet. I think in the slightly longer term, and by that I just mean 5 or 10 years, I think there's actually a profound opportunity, which is to come together as a polis and get precise about what do we mean by justice or fairness with respect to certain protected classes. Does that mean it's got an equal false positive rate? Does that mean it has an equal false negative rate? What is the trade-off that we're willing to make? What are the constraints that we want to put on this model building process? I think that's a really profound question, and we kind of haven't needed to address it until now. And so I think there's really going to be a civic conversation in the next few years about how to make these concepts explicit. Okay, so the question of civics, I would be hard pressed to give you off the cuff a definition that would maybe be robust enough against all the nuances, but this question of how should a society be this has been one of the things in philosophy going back to the Greeks, at least, that is, in a way, I think, less of an explicit concern in subsequent philosophy. Plato in the Republic, of course, is talking about what does the ideal society look like, and this is, this is not as much of an explicit, the society, the polis, the civic unit is less present, I think, in more recent philosophy. And for me, it feels like it is now reemerging as one of the critical spheres, especially because of the influence of AI. That we are now needing to define these societal concepts in a very, very explicit way. We have a notion of what good driving looks like. We have driving tests and so forth. But thinking about a single, driving algorithm that's going to be driving millions of people, for tens of millions of miles every day. If there's only going to be one procedure for doing that, then all of a sudden we have to think a lot more carefully than we do when everyone instantiates a slightly different version of what being a good driver means. And so I think the question of defining a society's values, norms, I think it's going to be sort of a crisis in the next decade or two, but I'm ultimately optimistic about that. I mean, I think at the broadest level, most AI systems operate by, optimizing with respect to some function, some objective function. And we get to decide what that objective function should be. There are these maxims about, he who would trade liberty for safety deserves neither, or something like that. And if you look at something like algorithms for doing parole and probation, all of a sudden a question like that becomes extremely, is thrown into extremely sharp relief, where someone on the one hand says, here's this model that has an error rate of, X. Here's another algorithm that's more fair, but it has an error rate of Y. So, just statistically, on average, there's going to be more recidivism, or, we know that on average there's going to be more crime or more mistakes or whatever as a result of following this procedure. But we also know that it's more fair with respect to these protected classes or something like this. We as a society get to decide, what are the coefficients basically on the competing values that we have as a society. I think there are a number of problems that are all pretty tightly bound. I mean, concentration of power, concentration of wealth is itself, I think, is going to be. It already is, but it's going to be one of the major defining problems, I think, of the next century. Your comment about opacity, I think, is the other thing that stands out for me as being a problem. So, friends of mine who work at places like Facebook, for instance, Instagram, talk about machine learning methods in terms that I find kind of disconcerting, which is they say, we threw a bunch of these huge, machine learning models at our newsfeed. They're better than everything that we've come up with on our own, but no one really knows why, and no one really knows, what's going on inside the box. But we can't turn it off because it makes us too much money. What I find really interesting is that we have built a justice system that is in large part centered on the idea of explaining yourself. You've taken some action, explain yourself. What was the thought process that went into that action, right? You think about, I don't have a specific case in mind, but imagine someone shoots someone. A police officer pulls a gun on a suspect and shoots them, and it turns out they were unarmed or something like this. Their ability to explain the thoughts that they were having will have a huge impact on whether they spend their life in jail or get a 2-week suspension or something like this. And in some ways that strikes me as pretty flawed because, as we were saying, a lot of these decisions happen in 50 milliseconds. So the idea that you're going to stand in front of a jury and explain all of the factors that you weighed, that's bogus. The truth is, that all of this stuff was happening at a completely inarticulate level, and your ability to reconstruct an explanation for that or confabulate an explanation for that will have a huge determination on what happens to the rest of your life. And so, I'm totally with the argument that the giant neural networks are black boxes, but so are we. That's true. But I think there's something unsettling about this idea that, if a classic if-then-else computer program does something, we can go back and say, okay, here's where things went wrong. This was the problem. That our entire notion of legal responsibility and justice depends on the ability to explain why something happened. And so as we start to deploy these systems that basically can't do that, or we can't peer into them and understand why they did something, are we going to have to somehow engineer in an ability for the system to kind of self-report? But again, it's not always... In many cases, there isn't an answer. It's like, why did you take this action? Well, these edges on this, neural network graph were weighted this, and so this thing happened. That's not necessarily a satisfying explanation. But we have a justice system that's dependent on motive, on intent, and all these things. So academically, my background is I came out of this math and science and engineering magnet high school, and I went to Brown University and studied computer science and philosophy, and double majored in those. And along the course of my undergraduate trajectory, I decided that what I really wanted to be was a writer. And so I went to graduate school and got an MFA in creative writing. I was probably one of the few people to ever go from the computer science department into an MFA program. After graduate school, my career has been in writing nonfiction books. My first book is called The Most Human Human, and it's about my participation in a Turing test competition, which I'm sure many folks will be familiar with, but the basic idea is you have humans and computer programs claiming to be humans in a chat room, and a panel of judges has 5 minutes to figure out, which are the real humans and which are the imposters. So I took part in the main Turing test competition in 2009, and my first book is both a recounting of that experience, but more broadly, looking at the history of artificial intelligence itself and the history of, within philosophy, how have humans answered one of the longest standing questions in philosophy, which is, what is it that makes humans unique and distinct and special? For 2,500 years, you go back to Descartes, you go back to Aristotle, philosophers have answered this question by contrasting ourselves with animals. And so in many ways, I think that computer science and AI specifically has inverted a 2,500-year-old question, which for me is very thrilling. We we now think about what defines and characterizes human intelligence by making a comparison to machines rather than to animals. And it's just completely changed the framework by which we think about, the human experience. So that the book kind of explores that question. And more recently, I published a book in collaboration with Tom Griffiths, a cognitive scientist at UC Berkeley and a good friend of mine, called Algorithms to Live By, which looks at human decision-making through the lens of computer science. So the basic idea is that, there's this huge class of problems that we face in everyday life, whether it's deciding, where to go out to eat, or what house to live in, or how to manage, our limited space in our house or our office, or how to structure our time, that take on a particular structure as a result of our finite information, finite time, finite ability to compute. But we think of these as intrinsically human problems. They're not. They're closely parallel a set of the canonical problems in computer science. And so this gives us an opportunity to learn something about the problems that we confront in our own lives and how to make better decisions in our own lives by thinking about human problems through the perspective of computer science. Yeah, Gigerenzer's work is on heuristic decision making is very relevant here. So one of the fundamental premises of theoretical computer science is that we can, in effect, grade problems by how hard they are. And there are certain classes of problems that are so-called intractable, where there just is no efficient way to get the answer reliably. And what computer scientists do when they're up against intractable problems is they have this huge toolkit, relaxations, regularizations, randomized algorithms, and so forth. And one of the things that emerges is that in many cases, getting an answer that's pretty close most of the time is better than grinding your way through to the exact solution. One of my favorite examples of this is in this area called primality testing. So most of encrypting the web relies on generating these huge prime numbers. So that means that we need good algorithms for determining whether a number is prime. And the algorithm that's used today in practice is called the Miller-Rabin test, which is wrong a fourth of the time. And to me, this is extremely fascinating. So I've talked with engineers at OpenSSL and people who do work on encryption, and I've said, well, how many Miller-Rabin tests is enough if they're wrong 5% of the time? And the answer is, about 40. And I just love that we've had to fix the amount of certainty that we demand in this application. And in this case, someone actually, as recently as 2002, I think, discovered a polynomial time algorithm for testing primality, but we still use the one that's wrong a fourth of the time, and we just do it 40 times. And so I think there's a powerful message there in thinking just at the broadest level about rationality. What does rational thought, rational decision-making look like? I think there's this idea that there's kind of this bias that we have that rational decision-making means always coming up with the right answer or considering all the possibilities, all your options, following like a reliable process, a deterministic process is going to give you the same answer every time, arriving at an answer that's definite, it's both precise and certain. And computer science, I think, offers us, in many ways, a better standard than, for example, economics for thinking about rational decision-making when you're up against what is just a genuinely hard problem, which is you don't have the luxury of computing all possibilities. You don't have the luxury of arriving at the same solution reliably with total certainty. And so in this case, I think what emerges is a standard of rationality that is, I would say, more useful, more approachable, and more human. one of the things that interests me is in these domains where we can identify, human decision making falls into a certain category of problem where we know what the optimal algorithms are for that class of problem. So, for example, there's a class of problems called explore-exploit problems, where you have a limited amount of time and you have to divide your time between gathering data and using the data that you have to get some kind of reward. The classic study, I think it's from the 1970s, Amos Tversky, had a box with two different lights, and one of the two lights would go on at any given press of a button with some probability. Let's say this one went on 40% of the time, this one went on 60% of the time, but you don't know that ahead of time. You've got 1,000 opportunities either to observe which light turns on or to place a bet on which light you think will turn on, but not get to observe it and not know the result of your bet until the end of the study. And so this is a case where you can work out the optimal way to play this game, and it turns out to be something like observe 38 times in a row, and then whichever light turned on more, blindly make a series of 962 bets on that light. And so, okay, we can say this is the optimal strategy for this game. Then there's the question of what do people actually do when you give them this task? Do they do anything remotely like that? No. What they do is they observe for a little while, they put a series of, 5 or 10 bets or whatever, then they go back to observing, then they go back to betting, then they go back to observing, and so forth. And to me, this is really interesting. There's always an interesting moment where you discover a dissonance between human behavior and the prediction you'd get from the model, which is either people are just doing it wrong, or somehow the model is failing to take something into account. Maybe the people are solving a different problem than the one you're modeling. So in this case, someone looked at the data for this study and said, well, if the rate at which these lights are turning on is on a random walk, then human behavior is actually pretty close to optimal. It's exactly the type of thing you'd want to do. You'd want to observe for long enough to kind of pin it down, make a series of bets until the point at which it might have drifted away, reobserve, and so forth. And in the literature, this is known as the restless bandit problem, the idea of this process that's on kind of a random walk. And what's so fascinating to me is, so people are presented with a static bandit, but they're solving it as though it's a restless bandit, and so they're missing out on some payout that they could have gotten if they'd done the correct thing. And you can ask, well, okay, we told them very clearly at the start of the study that these probabilities were fixed. So why are they behaving as though they're on a random walk? Well, I think a fair answer to that question is, they're subjects in a research study. Why would they believe what you tell them? The experimenters famously lie to research subjects all the time. And so I think, in many ways, it's quite reasonable to say, even though I've been informed that these lights are on these constant probabilities, I'm going to keep checking because I don't totally believe that. And the even more interesting thing to me is that the restless bandit problem still is considered an open problem. We do not have good, efficient, optimal strategies for the restless bandit problem. And so in many ways, not only are humans solving a subtler version of the problem than the one we were originally modeling, they're solving a problem where we don't really have good models yet. So that to me, there is a really fruitful dialogue between, the lab data that psychologists and cognitive scientists are getting, and the optimal strategies that computer science is discovering, and each informs the other, and I think at the broadest level it points toward, in my view, it reclaims a little bit of rationality for humans. That I think it's easy to conduct a study like this and say like, oh, people are dumb, they're doing a strange thing, or they're doing kind of an uninformed thing. But in many cases, I think this is a very good example where a closer look reveals that in fact people are doing an extremely subtle and in many ways correct thing.